clearly. What do you think? Okay, we're going to pull this down so we have a sharp quality down. How are you guys doing today? I'm doing fine, thank you. I missed my bus, and then I missed my stop also. So I'm late, but thank you so much for not leaving in the first step. I really appreciate that. So I'm an instructor for this class. My name is Shahera Jannah, and I prefer my Gmail to contact. You can email in my CUNY email, but I don't have the CUNY email in my phone. So unless I sit on a laptop, unless I use the laptop, I cannot see the email. Done. Anytime you want to tell me anything, I prefer Gmail. Office hours, Wednesday after class. Sorry, not after class. I have another class after this class. So 4:30 before class. Wednesday before class, but you should let me know before that you're coming so that I can be there. Sometimes in our office room we don't have space because every instructor holds their office hours in our office room. So if you tell me you're coming, then if they have no class here, I'll be here early. And if they have a class, then I'll arrange a place to meet. Here's our syllabus. I posted on Brightspace last night. So if you haven't taken a look, please take a look, read all the details. I'm going to go over only a few things. For example, the textbook. This is our textbook. It doesn't have any PDF version as far as I know. So if you want to buy, you have to really buy the physical book, not the PDF version, but new book. From the textbook, I'll assign homework after every section we cover, and I'm going to collect them. I'm planning to collect them through online through Brightspace instead of physical copy. It's easier for me to store everything in there. So I'll decide that. I'm still thinking. Last time I collected physical copy and then checking the physical copy, I didn't have the strength. So I was thinking, well, instead of checking every single question, I can just give you points for completeness. As long as you complete all the questions, then you get the credit. Okay. But before every exam, I'm trying to give you a bunch of questions, and then I'll check those questions. Exam, we have 2 in-class exam and 1 final. The in-class exam, or including the final, or 80% of the grade, and the homework you're going to do, every section homework and the review homework, 15%, and your attendance and participation counts 5%. And this is the grading table I'm going to use at the end of the semester to calculate your grade. And the 2 exam dates, approximately these 2 dates, September 24 and October 29. But if something happens, then we may move them around. So they're not fixed, but I'm trying to follow that.
I don't think we had class.
See, I didn't know so yeah, I have to check and then fix that. So this is just the date I approximated based on how many classes we have. So after that many classes, I was going to give you the first exam and that many classes. So yeah, I have to check the dates. Thank you for telling me. About the exam, so we had 2 in-class exam and 1 final. So one of the exam grade will be dropped. So if you have an in-class exam lowest, it will be dropped and the final exam will count it twice. But if the final exam is the lowest one, it will be counted once, and the 2 in-class exam will be counted. Did you guys understand what is said? Okay. Usually this is how all the math class works here. Like final exam count twice, unless final exam is the lowest grade. Attendance is mandatory. Try not to be late, like me today. Try to be early. And during the lecture, please no cell phone, no laptop. You can use tablet to write, but nothing to have a chat or communication in the outside of the classroom during lecture. You can use them after class or before class, but please not during class. We have Dolciani Tutoring Center. So anytime you need help with anything, not only with this class, but with every other class, anything you need help with, go to the 7th floor, the East building, and then they have one-on-one tutoring or group tutoring. So seek help from them. We can have a scientific calculator in this class during exam, but no graphing calculators. And to do the homework, you can do anything. But as long as you can show your work, you get a credit. Academic integrity, basically saying don't cheat. If I see you cheating, I'll take your exam, give you 0, and if you keep doing that, you fail in the class. If you have any type of disability or you need help with anything, go to the accessibility center, talk to them, they will let me know, so you get extra time during exam. And if you need any other special accommodation during class, they will fix everything for you. So this is the location, East Building 1124, and then blah, blah, blah. So what did I put before? 24. September 24, no class, yeah. So it will be 29, September 29. Let me fix it now. September 29. And then October 29. So we do have class October 29, yep. So after 15th lecture and 7th lecture, yeah, not bad. So we have 7 and then our final exam. Or maybe I can move 29 to November 3 or November 5. What do you think? October 29. Well, we'll decide it later, okay? But this is my plan for now. We have 2 weird days, October 14 and 24. 14 is Tuesday and 24 is Friday. Even though these are Tuesday and Friday, we're not supposed to have class, but we are going to have classes because they follow Monday schedule. Our last day of class will be December 15th. So most likely our final exam will be on 17th, I assume, probably. Okay, that's all about syllabus. Any question? Comments, concerns, complaint? Nothing yet? Great. Okay, so before I start the lecture, do you guys know what is matrix algebra is? Does anybody have no idea? Like somebody know idea? Go ahead. I don't think we actually don't draw them. We complete them. We work with matrices a lot. So this is the baby version of the linear algebra. Linear algebra is a large field. We take only the matrix portion from linear algebra and just introduce you to the basic operation of matrices. Okay? So this one should be easy one for you guys. Most of you guys are which major here? Computer science. So yeah, this is a piece of cake for you. Go ahead. No, you're fine. Okay, So our first section is 1.1, or chapter 1, system of linear equations. So we have different types of equations, but here we're going to talk about only linear equations, means lines. So we have a linear equation. If we have n unknowns and m many equations, we can write them with different coefficients. For example, a1x1 plus a2x2 plus a3x3, a1, a2, a3, all of these are numbers, they're coefficients. x1, x2, x3, all of these are variables. And we add them, we set them equals to some type of numbers. We call them constants. So that's how we write some linear equations. We have linear equations, but a bunch of them. A linear equation of 8 equations in n unknown. Then we can write them as one after another, all the equations. If you put them in this way, if you order them, then instead of working with a bunch of equations physically, we try to make them simpler so that you can work easily. So what we do is, instead of writing all the variables, all those signs, positive, negative, everything, we omit all of them from the equations and we only work with the numbers. We put all the coefficients together and then all the constants together in a big matrix. And this matrix is called augmented matrix. In the augmented matrix, on the left side, we have the coefficients of the variables. So this is called the left side coefficient matrix. And the right side, in the right side of the equation, all the constant, we call the constant matrix. So augmented matrix is consisted of two matrices, the coefficient matrix and the constant matrix. So sometimes people use a bar to separate them, so you can easily identify which one is our left side, which one is our right side. But most people don't like the bar; they just put everything together without any bar. So you have to assume the last column of the augmented matrix is a constant matrix. Note that the unknowns in the equal sign are omitted. Okay. So if you have a system equations ax equals b, where ax, there are a bunch of numbers, bunch of variables, then this equation we can write with the augmented matrix in the form a and then vertical bar b, or without any vertical bar, it's a b. You assume that there's a vertical bar between a matrix and the b matrix. And here a means the coefficient matrix and b means the right side, which is the constant matrix. For example, this one. We have x plus y plus z equals 5, 4x minus z equals 2, 7y plus 3z equals 4. Instead of working with three equations, we can simply convert them into matrix by placing all those coefficients here and all those constants on the right side. See, here I don't have any bar, but you assume that these three numbers are the right side of equal signs. And if you are missing any variable, replace those coefficients with zeros. So if your variable has a coefficient, you write that down. If you don't have any variable, you place 0 for a placeholder for this variable. So in this matrix, this is the augmented matrix. In this matrix, which one is coefficient matrix? No, before that, which one is constant matrix? Go ahead.
One on the way up.
On the right. So here, give me 1 second. So here on the right side, this is our constant matrix. And which is our coefficient matrix? That? The left side. The left side. The 3 columns you see? The 3 columns gives us the coefficient one. So whether you see the bar or not, it doesn't matter. You have to know that the last column is a constant. Now let's do some example. We have these 4 equations in 4 variables. It says first write down the coefficient matrix. So who would like to help me writing down the coefficient matrix? Go ahead. 1, 2, 2, 1. Then 0, 3, 1, -2, 0, 0, -1, 2, 4. And then you place the 2 square bracket on the side. That's all you have to do. You have 4 equations. If they just write down the coefficient matrix, you write down the coefficient matrix. No variable, no symbol, no signs, anything. Any question? Easy, right? Piece of cake. Now the next one says, write down the augmented matrix. So who would like to help me with this one?
1, 2, 3,
1, 2, 2, 1, 5,
0,
0, 3, 1,
-2,
-2, 1,
0,
0, 0,
-1,
-1, 2, -1,
0, 0, 0,
0, 0, 0,
4,
4, 4. So this is the augmented matrix. If you want, you can place a bar. If you don't want, it's also fine. Question? No? Now you try this one. Just for practice. Write the augmented matrix for this these many system of triangles. You have 5 variables with 5 equations. And it's a good time. Let me see your names. So I'm going to pronounce your name. When I make a mistake, please fix me. Kaylan? Is it Kaylan or Kaylan?
What's the last name called?
You.
Yeah.
Kaylan.
You can call me Kevin.
Kevin?
Yeah.
Kevin? Okay. Now, Kitila? Alvin? Darius?
Yeah.
Is it Darius?
Yeah.
Brendan? Hanar? Hanar, right?
Yes.
Hanar. Joseph?
Yeah.
Oh, you have 2 Brendan.
Yeah, I'm also Brandon.
So Brendan R and
Yeah.
Brendan C. Okay, Brendan. Brendan, did I have you?
You did.
Pre-calculus.
Yeah.
That's why I look so familiar. I was like, oh, which one's the close? When? Winston, right? Jane? Michael or Michelle? Michelle. 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 Her name is Michelle. Abigail? Shuffle. Gibran, right? Christine? Jack, Edison, Hibu,
Yeah.
Hibu, how do you pronounce it?
Hyobu.
Huh?
Hyobu.
She, I didn't see any S.
Oh no, he, like, Hyo.
Shio, oh, Shiobu.
Yeah.
Shiobu, okay. She, oh, Shiobu. And I can see your last name, Rahman. What did you write your first name? Maisha. Maisha? Okay. Maisha. So did everybody sign it? Did they call all of your name? Great. Now, who would like to give me the augmented matrix? Valentia? Gibran. 11111 5 201 -2 1 0 0 4 1 -2 1 3 zeros, right? 0 0 1 -3 0 and if you want you can place a bar. Good job. Do all of you have the same thing?
No.
What mistake did I make?
2 lines is wrong. So it should be.
Oh yeah, the second column, the second row.
0 2.
There is a 0, so 0 2 1. Thank you. Any other mistake? 2. Now you're going backward. They gave you the augmented matrix. Can you also write their equations? Ready? Who would like to give me the equations now? Go ahead. But can you have all the x?
Well, no, it's gonna be x1, x2.
5x1
2x2
minus 2x2
plus 1x3
plus 1x3
equals 3.
equals 3. Perfect. The second line.
2x1
2x1
x2
plus 3x2
minus 4x3
minus 4x3 equals 0. Perfect. Any mistake in this? Great. So now you know how to go forward and backward. Would you like to try this one?
I have a question.
Go ahead.
So in the first example you gave us, you used x, y, and z. But would like x1 and x2 do it the same as x and y? Because
So here we have 3, we can put x, y, z. But if you have a bunch, for example, if you have 7 of them, 7 variable, x, y, z, and then what? So that's why instead of having x, y, z, people like to use x1, x2, x3. But you can use x, y, z. Let's do it with x, y, z. So I would like to try this one with x, y, z. Easy, right? Come on, go ahead. Volunteer. Okay. So go ahead. Okay, x1, x2, no problem. 2x1 plus plus x2 plus 4x3 equals -1. 4x1 minus 2x2 plus 3x3 or 5x1 2x2 plus 6x3 -1. Perfect. And if you want, you can put x, y, z instead of x1, x2, x3 because there are only 3 variables. Okay, now, so we have seen we have many equations. We know how to convert them into matrix, but if you have a matrix, how to convert them into equations. Now, when you work with those equations, what happens to the solutions? You have 2 scenarios. Either you have a solution or you don't have a solution. When you do have a solution, we call them consistent system of equations. And when you do have a solution, there are several cases. Either you have one solution or infinite solution, or there could be more solution depending on your variable. Yeah. No, when every line works, you have only one solution or infinite solution. So when you do have a solution, you have 2 scenarios. Either it's one solution, means all the lines they're intersecting only at one places, or you have infinite solution, means all the lines you have, they're actually the same line. And then you have the second scenario, there is no solution, means all the lines you have, they're parallel to one another. They never intersect. Solution means where all the lines intersect with one another. So when you don't have a solution, we call them inconsistent system of equations. When we have inconsistent systems, that means our solution set is empty, means there is no solution. And when you have consistent system, it's supposed to be not empty. So if you have a consistent system of solution, consistent system of equations, but you get the result is empty, no solution, that means something is wrong. So consistent system has to have some solution, either 1 or infinity. And inconsistent, there are no solutions, so their solution set is empty. Now start with 2 by 2. If you have 2 by 2 linear equations, it means how many lines you have? If you have 2 by 2 system of equations, what does that mean? How many solutions do you have? If you have 2 equations, so how many variables do you have, or how many lines do you have? Go ahead, Maisha. 2. If you have 2 equations, if you have 2 by 2 matrix, that means you have 2 equations. Each equation going to give you 1 row of your matrix. So if your matrix has 2 rows, it's supposed to have 2 equations. And when you have 2 equations, it means you have 2 lines. And when you have 2 lines, there are 2 scenarios again. Yeah. Either the 2 lines you have, they intersect one another somewhere. What's with the penta? They intersect somewhere only once. So you're supposed to have only one solution. Or the 2 lines you have, they are the same line. One is just lying top of another line. So you have infinitely many solutions. Or the third scenario, the 2 lines you have, they're parallel. They never intersect, so we have no solution. Now, matrix-wise, when you solve system of equations, how do we know when it has no solution and when it does have some solution? So for example, we're not going to do it now, we're going to do that later. So when you have a bunch of equations, we can reduce them doing some type of math. And when you reduce them, at the end, if you end up getting something like this, where we have 2 equations, but the last line has a false statement. One side is 0, the other side is not 0, it's -2, or any other number. So anytime one of the row gives you something false, something not correct, in that case, we don't have any solution because we ended up getting something wrong, something incorrect. And when you solve, and at the end, you have the same number on both sides. There could be 0, there could be other number, but as long as the statement is true, you have the same number. That means you do have a solution, but not one, it's infinite solution. So true statement gives us infinite solution, false statement gives us no solution. And when you do have infinite solution, it means the 2 lines you have, or all the lines, here you have 3 lines. The 3 lines you have, all of them are the same line. So in that case, what we do is we set each variable a different variable, and then we represent each one of them with the different variable. For example, here, if you solve here, we get x2 equals x3, right? So what is the, well, we said, well, let's say x3 is a variable t, then x2 is also t. Then when you solve for x1, our x1 is 3x3. It means our x1 is 3t. We don't have to do that, but I don't know why mathematician found, well, this is fancy way of expressing the solution. I don't see it's fancy anywhere. So I prefer doing x3 is x3, x2 is x2. Like, I like to keep my variable instead of taking all the variables and making it complicated. I don't like that, but books tells me to do it. So if you like, you can do it. And if you like me, you don't have to combine into the variable. Just keep your variable. It's fine. What's your questions? 45, right? Okay, I still have time. Okay, so when you're going to solve, what type of operations we are allowed to apply? Not every operation is applicable, okay? We have restrictions. There are only 3 types of operations we're allowed to apply on our system of equations when you solve them. What are they? Any 2 rows, you can change them, interchange them, okay? So the first row, you can put it on the top. So the first row, you can put it on the bottom, and then one of the bottom row, you can put on the top. So you can change, interchange your rows. This is allowed. Then you can multiply everything by a constant. So constant multiplication. This is allowed. So swapping 2 rows allowed. Multiply by a constant, either positive constant, negative constant, fraction, any constant, it's allowed, unless unless it's 0. You are not allowed to multiply by a 0. You can multiply by any non-zero constant. And then lastly, you can multiply 1 row with a constant and then add or subtract with another row. So you can, let's say, multiply the first row by 5 and then subtract the 3rd row from there. You get a new row. This is allowed. But you cannot divide 1 row by another row. You cannot multiply 1 row by another row. This is not allowed. Adding 2 rows is allowed. Multiplying by constant is allowed. But multiplying the rows by themselves is not allowed. There's so many things not allowed. Only these 3 things are allowed. Swap them, multiply by a constant, add 2 rows. These 2 things are allowed. And when I say add, it also means subtraction. Because when you multiply 1 row by a -1 and then add the other one, basically you're subtracting the 2 rows. That's why when you work with matrices, we have only 3 things allowed. Swap 2 rows, multiply by a non-zero number, and then add 2 rows after multiplying by a constant. Okay. The left side is for system of equations when you don't want to deal with matrices. And if you do want to convert your equations into matrices, we have the same rules. Swap them, multiply by a non-zero number, and then add 2 rows after multiplying 1 row with something. Okay. So previously I said our augmented matrix, we have coefficients on the left side and the constant on the right side, right? Now, when you deal with system of equations, we actually have another type of system of equations. where we have all the constants to be 0. If you have a system of equations where all the right side, all the constants are 0, we call them homogeneous system of equations. And in a homogeneous system of equations, we love them because they definitely have some type of solution. Either one solution or infinite solution. But definitely they have some type of solution. And we homogeneous system must have at least one solution. Specifically, if all variables have the value 0, then it's easily satisfied. We call them trivial solution. For example, if all the variables are 0, we can easily check our solution. 0 plus 0 plus 0, 0. So 0 is a solution. So if you have a 0 as a solution, we call them trivial solution. Number of solutions of a homogeneous system. Every homogeneous system of linear equation is consistent, means the solution must exist. So, if you have fewer equations than variables, so you have more variables but less equations, in that case, you have infinite solution. For example, here, you have 3 variables, x, y, z, or x1, x2, x3, but only 2 equations. So more variables but less equation means infinite solution. The other one actually, the other way is the other direction is not true. If you have more variables, if you have less variables and more equations, it doesn't mean you have infinite solution or no solution. It could be anything. So it doesn't work backward. It only works this way. More variable but less equation means infinite solution. And with this, you're done at 1.1. I actually missed one more question here. There is one more question in the homework. Question 1D. So in your book, you have section 1.1. All you have to do is do question 1D, question 2, 4, and 5. And because my semester, you can do these extra. You don't have to do them, do it just for practice. But I will check these. Question 1D, question 2, question 4, and question 5 from section 1.1.
Could you go back to the allowed operations slide?
Oh, and the due date will be Tuesday, not Tuesday, Monday midnight. We don't have a class Monday midnight, so Wednesday midnight. Next Monday, we have no school. So you're going to meet after 1 week again.
For the homework, like it's 2 about to have like 6 questions, like sub questions, or it's 2, just 2.
Question 2 has 4 parts.
Okay.
But these are just asking you convert them, like write them the augmented matrix, or write the coefficient matrix. That's it. No hard stuff, just baby stuff. So these are fun homework, huh?
What is augmented matrix and the coefficient matrix?
Coefficient matrix is all the coefficients, you put them together. So when you have a bunch of equations, you have coefficients for each variable, right? When you put them together only, it's called coefficient matrix. But augmented matrix is the coefficient matrix plus the last column is your constant matrix, the right side of the equal sign.
So how do you know which matrix is which? Like when you
How do you know which matrix is which? Usually, no, it's okay. Usually, when you have a square matrix, it's easy to see. When you have a square matrix, for example, 2 by 2, 3 by 3, 4 by 4, then it means you have coefficient matrix because they're square matrix, usually. And other cases, like when you have 3 rows but 4 columns, like when they are not square matrix, the last column is the constant matrix. For non-square matrix, the last column is the constant matrix. Usually. But there's always some differences. So go ahead.
And then all the variables are stacked.
No, all the variables are invisible.
So then what is 0?
0 is for homogeneous system equation. Homogeneous means, for example, x plus y plus z equals 0. And then another equation is 2x minus 3y plus 5z equals 0.
But when you have 0 in the matrix, isn't that a variable?
0 is not a variable. 0 is constant matrix. Like the variable has coefficients. So coefficient goes on the left side of your matrix in the augmented matrix. And the right side of the equation, all those zeros, or if it's not homogeneous, then you have different numbers. They go on the right side, the last column in your augmented matrix. You'll get used to it, okay? So don't get stressed right now.
Will you ever get a matrix without specifically stating that?
No, I'll make your life easier.
Okay.
I'll tell you this is augmented matrix and this is coefficient matrix. I will tell you.
Would it be better to just put the bar like
Mhm.
separated?
That's why I love bar. But most people they don't like bar. So I don't understand why. Like when you see the bar, we can see clearly what's happening. Man, they want to make our life hard.
Oh, will these slides then go online?
I will put them, but I'm still making them. I'm still thinking. If I can make something on Brightspace that you can submit online, then I'll do that and then I'll send you an email.
It'll be easier to submit it online.
I know, like I don't want to deal with all those papers.
So should we just write the questions on like a slip of paper?
And even if you have to upload, you just upload as a PDF file in there, and then it will be easier for me to grade.
Could you go back to the questions?
Question 1D, only one of them. Question 2, 4, and 5. But these are baby work, like what we did today. Write the coefficient matrix, write the augmented matrix, rewrite the matrix into system of equations. That's all.
This is due Tuesday night.
Wednesday. Next week, Wednesday midnight.
Is this one on like a website or?
That's what.
Okay.
Textbook. Yeah. If you don't have the textbook, you can just go to the library. I think library has our textbook. Go to the library, take a picture, and then do that. I used to do that during my undergrad. If I didn't have a book, I used to go to the library, and then that time actually we didn't have any phones available. So we had to go to the printing center and then print all those homework out. All life was harder.
And the Department of Justice just, if we want extra practice?
Yes. They would like to do them, but I'm not going to pressure them because most of them says solve this, solve that. But we didn't even learn anything solving here, so I'm skipping that.
You get extra credit if you can get additional practice homework.
No. But you do have to learn one thing by yourself. Question 1D, it says solve using back substitution. Do you know what is back substitution? Let me go over a little bit. I wanted you to learn it by yourself. But it's okay, I can just start. So back substitution means you solve for the last variable, and then you keep substituting to the other variable until you solve all the variables. For example, if you have x1 plus x2 plus x3 equals 5, and let's say x2 plus x3 is 7, and let's say x3 is 1. Back substitution means take this x3, substitute here, solve for x2. When you're at x2, place here, place x3 here, solve for x1. So you're substituting backward. It's called back substitution. Any other question?
Back to what she said, if we do the extra question, extra credit, not that, but specifically, will there be extra credit opportunities?
In 116 now.
No?
But I'm going to put some extra questions in the exam as extra credit.
Okay.
Any other question, comments? I'll stop here today since these are first day. Let's do it one class, one section. And so next Monday we have no school. We are going to meet again next Wednesday. And then the following Monday, we do have a school, but I will not be here because I have to attend in a conference. I didn't tell you about myself, right? So I did my bachelor on applied math and my master's on pure math from City College. And currently I'm doing my PhD at Columbia on math education. So I'm doing my research from this semester. So I have lots of work to do. And I'm going to attend a colloquium. Basically, they're going to tell us about their research and everything. So I'm going to attend that next Monday. So next Monday, also you're not going to have a class. But you're going to have a school here, okay? I mean, you have other classes. But our class will not be here next Monday. Not next Monday, next Monday. These materials, I'm going to post them after I modify them, but I'm still fixing them. Homework is next Wednesday. Yeah, I'll post them. No problem. So goodbye, everyone. Enjoy your day, your evening. See you after 1 week. Go ahead, Maisha. Looking at all the metric operation is doable in the graphing calculator without your email. That's why, yeah. Scientific, yeah.
Yes.
But if they don't get me one, time for this.
There is a PDF.
We have 1 month, so you're fine. 1 month time, so you can do something about that. Our first exam will be October, not October. Today is September. September 20 something, right? 29. So we have, today is 27. We have more than 1 month. So you'll be fine.
Thank you.
No problem. And if you do talk to them, tell them to email me in my Q&A email. They told me I received a call from them saying that, well, they're going to email me, but I never received an email from anyone. Or my Hunter email. But I looked at the website from the faculty, and I didn't see an email because I was going to email you, but I didn't see an email from you. So in the syllabus, you have my Gmail. Email is there. Okay. Because in CUNY, I have so many emails because I was a student and I was a faculty at many schools. So I don't know which email they send it to. So it's better just to email me in my Gmail. I still get emails from Queen's College. So see, and I was a student here, so I have my student account, my CCNA instructor account, my Baroquimo instructor account. Like I have so many instructor accounts and so many student accounts. So I don't know. Go ahead. So if you do see them, tell them that my Gmail is there. Okay. That's a situation. Yeah. Is this a PDF book?
Yeah, I found it.
How did you?
I just searched it up for this thing.
Searched so many times, but I didn't find any PDF version.
I found it this morning, so maybe
Oh,
it was
would
close.
you mind sending me the PDF?
Yeah, on your email?
Thank you so much. Question.
Thank you, miss. No, I was just gonna let you know there's a PDF.
She's so many times, but it wasn't available.
Yeah, this is like my second time taking this class. Yeah, I'm really bad at it.
It was an older gentleman. I don't remember his name, but very different. Wasn't like this. He was really. I mean, I think in the summer too.
Did you take 160 or 260? Like linear algebra or matrix algebra? Which one?
Matrix.
It's
Matrix. Yeah, but I think the summer, because it was so condensed, made it really hard.
true.
Plus the teacher wrote me. But nah, I saw your name. I was like, oh my god, no way. I gotta get her. So yeah. How you been? Very good. Very good. Trying to find a job.
So you're senior this semester?
Yeah. I changed my major a bunch of times, which kind of messed me up. But I just gotta finish all like the maths, so that should be alright. Nice seeing you. See you soon. Have a good night.
You too. See you after 1 week.